Hello everyone and welcome to another video about SolidJS and Lightning. This one's going to be more SolidJS focused, and I want to talk about the different types of loops that SolidJS offers and the different ways of looping through elements. So out of the box, Solid comes with the for loop, and the for loop is made to go through a list of items where the items stay the same, but their index can change. So when you use for loop, you can actually go through and you get the item as a normal prop, but the index is a signal that you have to access as a signal. So that is a for loop. And then if you compare that to an index you loop through, and each of the items is a signal, but the index is not a signal. And that's the major difference between the two of these. And I'm going to show you some practical examples of what this means when working with Solid and Lightning. So here I have a little demo set up, and I have a for loop that's looping through a list. There's an array of 20 items, 20 poster items. And the first one we're going to look at is the normal for loop. So this is the SolidJS for loop. And so I have buttons set up here where I can switch between different arrays. So if I press these different keys, this will actually switch the different arrays that we have. And if I press this key, the /, it will actually reverse the same array. So we'll take that array and just reverse the items in that array. And so if we're using a for loop and we switch the items, and the easiest way to see this is actually with a console.log. So I'm going to switch the items. And what it's doing is it has a whole new array, and it goes through and compares the items from the previous array to the new array in the nodes. And it says these objects are not the same. So it goes through and deletes all the items and then replaces them with new items. So very inefficient, or can be inefficient if you use that. But alternatively, now what I'm going to do is I'm going to reverse the array, and you'll notice I can reverse the array, and it's not actually deleting any of the items, and that is the major difference. So, well, I'll show how you can check these things. So here I open the solid ops. So you can do Command P, open solid ops, which is what I already have open. And then I like to set a log point here. So here I'm going to set a log point, and I'm just going to do name value here. And that's going to show us all the properties that are being set when I change this. So now if I go back here and I'm just going to change again, I'm going to reverse the array again. You'll notice that all the properties that are set are only the new X values. So what SolidJS is doing behind the scenes is it's saying, oh, I have a new array of items. I'm going to go and compare it against the previous array of items. And it sees that all the objects are the same. So all it has to do is update the X values of each of those, each of the posters. So here's again the poster. We have the X equals an index times 210. So I turned off flex for the sake of this demo. And all the posters are being laid out via their index and putting in the item. So here again, if we just reverse the array, so we have the same items and we want to change where the items are in the array, it's good idea to use a for loop. And so I'm switching, it's only changing the X. And now what I'm going to do is I'm going to switch the items. I'm going to switch the array. And you'll see it deletes all the items. It has to then go through and create all the items. So it's setting all the properties back. So there's a lot more work that it has to do. And so this stuff is very important to understand for performance for different cases. Most of the times you're not going to have any issues. You can use a for loop, you can use the index loop, but there are certain cases where you have lazy loading or you have an infinite list, and you want to know the difference between these. So that is a for loop. Now I'm going to move on to, I think, index next. So what I'll do is I'll comment this one out, and we will use the index array. So here is the index one. And again, it's almost identical structure, but now we have index rather than for. And our item, we have to access it as a signal. And so now we have the same thing here. Let me reload over here. Yep, there we go. I might not have my server running. I do have my server running. Make sure I save it. You always got to save things. That's always what happens. So I save the file. Now it says index loop up the top here. And again, it's the same data, same thing that we're going to be doing. And I'm gonna reverse the arrays first. So this is reversing. If I click on here, reversing the arrays. So now what index does is it's setting all the properties. So it's going through, all it cares about is where in the array the item is. It's no longer doing a dirty check to say, is this the same object that was there before, or does this object exist in the array? It doesn't care about that. It's saying, I have a new item at index 0. I'm going to update all the properties to match this new item. So that's what it's doing. So if I reverse the arrays, look at all the properties that have to get set. So there's a lot of properties getting set. Now the big difference here, I'm going to go into here, it's going to set all the properties all the time, but if I change the array, you'll notice it didn't actually delete any of the nodes. So I no longer have the console.log for deleting nodes. And what it's doing is it's saying, oh, I have a new array of items. I already have 20 items that I created on the screen. I'm just going to go through and update all their properties. So it's not deleting the nodes. It's just saying, I'm going to update the properties. So this saves you the performance overhead of deleting all the nodes and recreating all the nodes. So index, a lot of times index is going to be the faster one to use rather than the for loop. And it's important to note that what you want to do is, when you use an index, again, the item is the signal. So the thing that you're looping through is the signal, and the index no longer is a signal. Now, I'm going to go through LazyUp next, because I think that was good for understanding that. So LazyUp is a special primitive that I wrote. And what LazyUp does is it gives you, it kind of, it puts the row inside of a component, and it includes an index. So it uses index inside of it. So you're giving it the items that you want to loop through. You're still giving it a block. And inside of LazyUp is an index. And what it's doing is it's taking the array that you give it and it's slicing it down to up count. So it only is creating 5 items on the screen. Okay, let me do a full reload because I think my array is reversed here. So now it's only creating 5 items, or it will only create however many items that you put here. So if we save it, you'll notice it created all the items. We're going to go back to 5. And the reason for this is a lot of times what you have on the screen is you have, and this is especially useful if you have a column with many different rows. What you can have is you can have a LazyUp on that column, and it will only create the 2 rows that are visible to the user. It won't go through and create all 10 rows or 15 rows. And especially if you have a row with 30 posters, you only want to create the 7 or 8 that are visible to the user at a time. And that's what this is doing. So it also has logic built in. So what it does again is it takes this array, it slices it down to only 5 items, and it loops through and only creates the 5 poster items. And then every time the user presses write, you'll notice 1 item is getting added. And all it's doing is it's saying on write, update my array to add 1 more item to the array. And then SolidJS is just going through and updating the UI. Now, the downside with this is that there is performance overhead. So if you are switching between rows, so you're going from one row to another row and it has to create a row, it might cause some jank because it's doing a lot of work to create that next row while also trying to animate. So there are things that I'm thinking about on how to solve that, which is one, adding like a delay property in here so that you can delay creating the next row for maybe 250 milliseconds or 300 milliseconds, or to have some kind of logic in here because the renderer has a notification for when it's idle, so that LazyUp maybe creates items while the renderer is also idle. So I have some ideas on improving that, but just again, making you aware of how this works. So the same thing with row. And what again I can do here is I can go into the console and we can go sources and we can see the properties that are getting created. So every time I press write, we got 1 new node was created. And so the node has to be created, all these properties have to be set on it, and the node is created. But the benefit of doing this again is you speed up the initial page load because you're not creating as many nodes and everything is lazy being created. So you're not creating nodes, you're using less memory because a lot of times users won't go through all the rows and add items. And even when they do, like going horizontal, there's no jank because there's one item, it takes less than 5 milliseconds to create it, and there's not heavy animations happening with this. So, okay, that was LazyUp. And again, so LazyUp is using index, which is why when you access the item, you're accessing it as a signal. Okay, so it's working the same way. It gives you an array of items, and then it's just populating the array or changing the array length, which is causing this to update. But since all the other items are the same, it doesn't have to update all those other ones. So it only adds a new one to the next item. All right. So now I'm going to go back through another different type of for loop because you don't have to use these primitives. So sometimes you might want to use just a normal map. So here in the JSX, you can actually do a map loop, which this is just loop through, map the array to new items. And JSX is made so that if you have an array of items, it will just create those items on the screen. So you don't even need the for loop. You don't need the index loop. But again, what happens is there's no magic happening here. Every time the active row changes or the items changes, it doesn't do a comparison. It doesn't do like, are you the same item? It doesn't do any of that. It just says, oh, you changed the items. I'm going to delete all these nodes. I'm going to recreate them every time, every time. Which, sometimes that's important to know and important to use that technique because maybe you are replacing items, or maybe you don't want to have those dirty checks that the for loop does or the index loop does because you know that you want to delete them all and recreate them all. So this could be an optimization that you can use and know about. But here we can again look, and if I can just show you, so all the nodes get deleted, all the nodes get added. Even if I reverse them, it's deleting all the nodes, re-adding them, and that's essentially because this changed. It has to replace it. So the signal fires off an event and says, I have to replace this. Okay. So the last one that we're going to look at is a little bit more interesting. So there is another solid primitive available called the list component. So this is a solid primitive. It is a list component. So here it is solid primitives / list. And this one is great. So this one is great. So if you have, let's say, a row with 10,000 items, or you have a grid, a TV grid, and you have hundreds of rows, the problem becomes like LazyUp is going to create all them, but it never does anything smart to like remove the ones that are not visible. The renderer does that behind the scenes, like it won't calculate nodes that are not on screen, but you still have those nodes. Those nodes still exist. LazyUp, what list does is it gives you the best of map and index. So both the item and the index are now signals. So you use them both as signals. And you might be like, well, why would I want this, right? So let's reload here. And the reason why you would want this is normally map destroys the nodes, or for destroys the nodes and recreates them if they're in a different position. With this, if you change an item from one location in an array to another, it won't actually delete it. So here we're going to go through and we're reversing the array, and you'll notice none of the nodes are deleted. The other cool part though is we can now add a transition to this. So transition, when the X changes, and it's better if you do like a really long time. So now if I go over here, and so now the X value, only the X value is being updated, and it's changing the X value and animating all those. So this is really useful if you have a list where you have 10,000 items. You could do something like LazyUp has, which is this active row could only be 10 items or whatever you have on the screen, and you could constantly replacing it and updating the index. So all this would be the same index, and by updating it, all these would be moving just based on their index in the array. So I hope to have another video on that, kind of explaining that in more detail. But I hope this was helpful for understanding the differences between for loop and index loop, and when you'd want to use one versus the other. As always, like, subscribe. If you have any questions for me, feel free to drop a comment, and I'd be happy to create a video for you. Thanks. Take care.